Okay, so we know that logarithmic functions are the inverse function of exponential functions. And we know the rules of exponential functions. When you multiply with exponentials, you add exponents. And when you divide with exponents, you subtract. We need to keep these properties in mind when we're working with logarithmic functions. So when you were looking at your quiz from the other night, you may have had some issues with that. Did any of you have issues with your quiz if you even got started on it?
Yeah, I didn't even take it.
That's fine.
Your quiz ain't due till tonight. I ain't done it yet. I'm not gonna lie.
Wait, it said it was due on Sunday, or am I just tripping?
She changed it to due to today now, right?
No, it's moved to next week.
Oh, dang.
Yeah. All right. So let's look at this example. If you have ln of x plus 8x plus 5, and we need to take the derivative of that, then it's 1 over 8x plus 5 times the derivative of the inside. What's the derivative of 8x plus 5?
8.
8. And then you can reduce that to the derivative is 8 over 8x plus 5.
Is that it?
That's it for that one. Now, if we look at another one, y equals the ln of 7x squared plus x plus 1. We want to take the derivative here. The derivative of any ln is 1 over that function times the derivative of the inside, which would be 14x plus 1. So the derivative equals 14x plus 1 over 7x squared plus x plus 1. The next one we're going to look at is a square root problem. Just like with all square root problems, we have to rewrite this function. So that's going to be the ln of x squared minus 13 to the 1/2 power. Now, with natural logarithmic functions, I don't know if you remember the properties of logs from pre-calculus. I doubt you remember that, and that's okay. We can rewrite this by bringing this 1/2 on in front. So that's going to be y equals 1/2 times the natural log of x squared minus 13. So when you take this derivative, bring down your 1/2 times the derivative of ln x squared minus 13. So that's going to be 1 over x squared minus 13 times the derivative of the inside, which is 2x. Now your 2's reduced, and the derivative is x over x squared minus 13. The next square root problem is y equals the ln of x times the square root of x squared plus 15. So initially when you look at this, you think, well, we have a product rule here. Well, we can make this problem even easier for us by remembering the exponential rules, that when you multiply, you add. So we can work backwards here and expand this. So that would be y equals the ln of x plus the ln of the square root of x squared plus 15. You may remember from pre-calculus when we would expand logarithmic functions or condense them. And so this is the reason that we worked on that, is because when you go to take the derivative of logarithmic functions, it actually makes it easier for us to work these problems out. I'm going to rewrite my square root problem like I did just a second ago. So the derivative of ln of x is 1 over x plus, I'm going to bring that 1/2 down in front, times the ln of x squared plus 15, so that's going to be 1 over x squared plus 15 times the derivative of x squared plus 15, which is 2x. So we can reduce the 2's, and we have 1 over x plus the numerator is x, and the denominator is x squared plus 15. You could stop there. There's no reason to get a common denominator and simplify it further. Are there any questions on those two problems?
They're okay.
Okay.
I thought this was gonna be something harder because I got there at the end of the notes the other day, and I said, "Oh my God, I can't even get this. How did I just miss this whole thing?"
Well, I have figured out now how to convert this into a video. So if you ever need to go back and watch any parts of this, you can.
Okay, this was definitely easier than I thought it was gonna be.
With my internet at home, it's not the worst in the world, but it's also not the best in the world. So it just takes about an hour to convert it and upload it, but which isn't horrible.
Yeah.
So it's not going to be immediate, but hopefully within an hour, it'll be on Canvas, this video.
Okie dokes.
All right, I'm going to do one more problem. This one is y of 9x over x squared plus 9. Instead of doing the quotient rule inside the parentheses here, let's think about our exponential rules that when we divide with exponents, we subtract. So I'm going to break this division up and make that ln of 9x minus the ln of x squared plus 9. And then I'm going to take the derivative of each of these functions separately. So that's going to be 1 over 9x times the derivative of this inside, which is 9, minus 1 over x squared plus 9 times the derivative of this inside, which is 2x. Now reduce this. I can cancel these 9's out, which gives you 1 over x minus 2x over x squared plus 9. And that's all there is for that one.
So why don't you do the common denominator and reduce it?
You absolutely could. It's just more work and it's not necessary.
All right, cool.
So you have 5 problems online to work on. I'm not going to make those due till Sunday at midnight. And then on Monday, we will plan to get together again at 2 o'clock. Do y'all want to meet earlier, or is 2 o'clock good?
I like
2 o'clock
2
is good. 2 o'clock is good. Don't know earlier. No earlier. I might not be awake.
Yeah.
Okay,
I like 2.
that's fine. I'm flexible. It's not like I can go anywhere. All right, so perfect. So I have also, if you notice in Canvas, when you log in, this is hopefully how you got in today, but when you log into Canvas, on the left-hand screen, I've put 2 new buttons up there. There's a chat button and there is a Zoom button. So when you click on that Zoom button, those will be the links for each one of our meetings. And we will meet on Mondays and Wednesdays at 2 o'clock. for calculus. So next week we will finish up chapter 5, and then it'll be the following week before you have your chapter 5 test. And that will be online.
Okie dokie.
Okay, if y'all need anything, email me, text me, and we can also meet in Zoom if we need to talk live. So it's not a problem.
Wait, are we done?
We're done.
Oh Lord.
Better than class?
I mean, Lord. Yeah, this is like we're barely doing anything.
Exactly.
No, honestly, we got so much of calculus already done that we're at a really good place if this is gonna happen.
Oh, bet. Well, I mean, hey, more, you know, the less the merrier in this case. You know what I mean? So.
I know.
I think people are like hoping like this lesson's like an hour long.